Hello, my name is John, and in this Far From Standard video, I'm going to be talking to you about units of unsaturation. So to understand units of unsaturation, we first need to go over what saturation means. Quite simply, saturation means that all the atoms in a molecule are all single bonded to each other, and thus there are only sigma bonds present. Let's first look at hydrocarbons. Hydrocarbons are molecules that contain only carbon and hydrogen. It's in the name. Hydrocarbons contain only C and H's. Saturated hydrocarbons are those that are all single bonded to each other and saturated with hydrogen. They follow this molecular formula here, where N is the number of carbons. Let's first look at an example. Propane is a common hydrocarbon found in fuels for engines. And propane has 3 carbons, and thus, if we put it into our formula here, 2 times 3 plus 2 equals 8. It would need 8 hydrogens to be fully saturated, which it has. So if we look at the structure of propane, we see that they're all single bonded to each other. All the carbons are all the hydrogens. The carbons have their octets filled, and the molecule is totally saturated with hydrogens. Yep. So, what about molecules that have multiple bonds, or cyclic molecules? Well, cyclic molecules, which are rings, or double bonds, or triple bonds, are units of unsaturation. And one ring would equal 1 unit of unsaturation. One double bond would equal 1 unit of unsaturation also because it contains 1 pi bond, and 1 triple bond equals 2 units of unsaturation because it has 2 pi bonds. So we need to take that into account. Units of unsaturation influence the molecule by how other atoms are bonded to it. So we have our first rule here, which is the 2n plus 2 rule, derived from the saturated hydrocarbon molecular formula. Okay? Let's first compare a saturated hydrocarbon with a hydrocarbon that is not saturated. So if we have ethane, C2H6, we would need 6 hydrogens to make it fully saturated, which it is, and we see that in the structure here. Everything is single bonded, valence shells filled, and hydrogen saturating the carbons. Well, what if we have C2H4? This is ethene, also known as ethylene. It has the same number of carbons, but it has 2 less hydrogens. So if I try and draw this out in the same way I drew out ethane, I'll have 2 sigma bonds that are just floating there. I don't have any hydrogens to put in there. And so the only way to satisfy the octet rule for both these carbons is to make these 2 sigma bonds into 1 pi bond, just to bond them together, which I'll do here. And this is the structure of ethene. And so you see that when we compare ethane and ethene, we realize that this saturated hydrocarbon formula can be used to evaluate saturation. More importantly, this rule number 1 here, 2n plus 2, is a way to find what you need for the molecule. What are the basic needs for that molecule in terms of being saturated? Now, what fulfills these needs? Well, there are only 2 things. Hydrogens, which we know from these examples can fulfill these needs. Also halogens, they are known as hydrogen equivalents. Both halogens and hydrogens are normally found single bonded to other atoms, and thus only hydrogens and halogens can be used to satisfy the needs of a molecule. So, let's look at a molecule that contains things besides carbon and hydrogens. You're most likely going to be running into these kinds of molecules throughout organic chemistry, and so it's important to know that other atoms change the needs of the molecule. So if we have things like nitrogen and oxygen, these are normally bonded differently than carbons and hydrogens. Okay? So if we look at oxygen, for example, oxygens are normally bonded to 2 things, like so. Anything else in the column that oxygen is found in, like sulfur, is also bonded to only 2 things. And its other 2 non-bonding pairs are just found on oxygen like that. So what about things like nitrogen? Well, nitrogen is bonded a little differently. It likes to be bonded to 3 things, like so, and then it has 1 non-bonding pair. So things in the nitrogen column, like nitrogen obviously, and phosphorus, would need to be bonded to 3 things. So this changes the needs of the molecule. If there's an oxygen present, you don't need to add an extra equivalent halogen or hydrogen. But if you have things like nitrogen present, you do. You need to add 1. So let's look at an example here. We have C3H6NOCl as our example molecule, and we're going to go through the process of finding the units of unsaturation based on our 2 rules here. So the first thing we do is we look at how many carbons we have, and we apply rule 1 to find what we need. So we have 3 carbons, which will give us 2 times 3 plus 2 is 8. This is the basic needs of the molecule. Well, we also have things besides the carbons and the hydrogens present. We have nitrogen and oxygen, and we know that oxygen doesn't affect this, but nitrogen does, so we need to add 1 more. So what we have is we have 2 times 3 plus 2 equals 8. That's based off the carbons, and then we have 1 nitrogen So plus 1 equals 9. This is the basic needs of the molecule found from Rule 1, the 2 plus 2 rule, what you need. Rule 2 is looking at what we have. Well, in the formula we have 6 hydrogens, and we also have a hydrogen equivalent, chlorine. So we have 6 plus 1 equals 7. And so this is the crucial point. There's a difference between what we have and what we need, 9 and 7. And this brings up Rule 2 here, where units of unsaturation is equal to what you need minus what you have divided by 2. So if we follow this, we see that 9 minus 7 over 2 equals 1 unit of unsaturation. And so there's a lot of ways to draw this out. I'm sure you'll be asked on tests to draw molecules from the formula to the structure. So one of the ways to draw this out is just to put the hydrogens here on the carbons, taking into account that there are 6 of them. And we'll put our 1 unit of unsaturation between the carbon and the nitrogen, because nitrogen likes 3 things bonded to it. And then everything else is left as is. Where oxygen is normally bonded to 2 things, it has 2 non-binding electrons. Same with nitrogen. It only has 1 non-binding electron. And so, as you can see, applying this process, going from Rule 1 to Rule 2, you find the units of unsaturation, and it's a quick way to go from the formula to what the structure is, and it's more effective because you're not going to be guessing and checking what the structure could be based on the formula. You actually know if there's a unit of unsaturation present, like a double bond. And that is how you use these rules to find the units of unsaturation.